check attendance. See Jennifer. Oh, no, don't do that. This is Wednesday. Keyshawn. It's finally good to meet you, Keyshawn. John. No, John? Wilfred. Janaya?
Yeah.
Did I say that right? Shirley. Where's Shirley? And Leslie. So we're only missing John. Okay. Now I need to tell you guys a couple of things here. I can't talk with this, so. There are several things that I am supposed to teach you. And I have been trying to do this all week with my at-home students. And it's not working. So I'm going to drop it and try a different approach here. So make sure you have a calculator. And let's reset our calculator before we get started. Now, don't push that button on the back. Okay? It says reset, but don't use that. And the reason I don't want you to use that is that's a factory reset. Quit looking at that button, young lady. You're making me nervous. It's a little recess button there. But if you press that button, it does a factory reset. And there are certain programs we put in here that you need. If you reset it to the factory, you're going to lose them. So when you reset, always do the facial reset. That's where you press second, plus 7, 1, 2. Well said, young lady. So second plus 7, 1, 2. Now I want you to take a few notes here before we get started. Yeah, now if you need a composition book, there's some on the table over there. So we're going to talk about are systems of 3 linear equations. How many of you got my emails today? Anyone?
About the eye?
Yes.
You got an eye? Okay, I got that.
Okay, I don't know if anybody in here got an eye, but you've got 2 options if you did get an eye. You can go back and make up all the work you missed, or you can do one assignment and make it up. Now, obviously, the one assignment is probably the way you want to go if you're just concerned about your grade.
Well, I can redo everything?
Well, that's the first option.
Okay.
Second option,
I don't got an eye, but I want to redo everything because I got to.
I don't think that's going to work for you. This is only restricted to people who didn't pass, I think.
Oh, just the eye?
Yeah.
Oh.
So if you didn't get an eye, you probably can't do it. Now, that's my understanding. If you really want to do it, I won't stop you. But it's not the way I would do it. Okay? Okay, systems of 3 linear equations. Now, when you were in Algebra 1, you looked at stuff like 2x plus 3y equals 12, and maybe 4x minus 3y equals 8, something like that. And you had 3 ways of solving this. You could graph it, and wherever the lines cross, that was the answer. Or you could eliminate one of the variables. Or you could substitute for one of the variables. Now that's Algebra 1. In Algebra 2, we don't work with 2 variables, we work with 3. So graphing doesn't work. I mean, you've got a 2-dimensional calculator, and you need something that's 3-dimensional for that to work. So that's not going to work for us. We can still do elimination. It's tedious, and it's time-consuming. We can still do substitution. But the real way to do this is with a matrix. It's simple, it's easy, and you can handle as many variables as you like. Now, when you're working with a matrix, there are two things you need to know. One is called the Gauss elimination. And we use that to get a row echelon form. And we call that an REF. Now, I don't know if you guys know who Gauss was, but he was a really famous mathematician. And there's a story about him that when he was 5 years old in kindergarten, he was a worrisome child and kept pestering the teacher. And finally, the teacher told him to go to his desk and add all the numbers from 1 to 100 and don't come back until he finished. So he went to the desk and came right back up and gave her the answer. And the answer was 5,050. And she didn't understand how he did it, but this is what he did. He looked at the numbers from 1 to 100. And he saw a pattern there. When he added 1 to 100, he got 101. When he added 2 to 99, he also got 101. When he added 3 to 98, he got 101. When he added 50 to 51, he got 101. So he saw there were 50 pairs of numbers, and they all added up to 101. So when he multiplied that, he got 5,050. And it took very little time to do that. He was a very intelligent guy. He may have been one of the last complete mathematicians. You guys know what a complete mathematician is? Well, mathematics right now is really complicated. It's a huge field. There's one field of mathematics that deals with problems that you will never be able to solve. And that's all they do is they look for those. There's another field of mathematics where they're always looking for the largest prime number. They're called prime chasers. And that's all they do is look for the next biggest prime number. There are other mathematicians who major in topology, the structure of shapes and things. Then they're algebraists. And, I mean, the field is huge. A complete mathematician understood all of that. And we haven't had one of those since the Civil War. And we will never have another one. It's just too complicated. Anyhow, that's what Gauss is. Now, we use Gauss elimination to get this. Now, the row echelon form looks like this. The key there is all these numbers on this diagonal have to be 1. And everything in front of them has to be a 0. Now this diagonal here, I forgot what I told them the kids to call it now. Let's see if I wrote it down. Oh, I know what it is. It's called a pivot. So you want 1s on the diagonals and 0s in front of that. Now, Gauss had an assistant named Jordan. And they worked on this and developed another method. Now you use this method when you want to get the reduced row echelon form. And this is called the RREF. Now this is tedious, but I'm supposed to teach you how to do it. But I'm not going to teach you how to do it. Because if I did, you probably, oh, I'm sorry, did I take that away too fast? good? Everyone's good? Now, to do these three techniques here, there's several things you have to know. One, when you have a matrix, you can multiply a row by a number. Two, you can add or subtract rows. And number three, you can move rows around. Oh, sorry, guys. Wasn't paying attention. Okay. Now, when we talk about matrix, we always list the number of rows and then the number of columns. So if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, my rows go this way. So in this case, I have 3 rows. My columns go this way. So this becomes a 3 by 4 matrix. If I had this, this becomes a 4 by 3 matrix. 4 rows, 3 columns. Now we're going to want to multiply these. If I'm multiplying a matrix, these two numbers here have to be the same. So I can multiply a 3 by 4 with a 4 by 1, a 4 by 2, a 4 by 3, a 4 by 1067. These middle numbers have to be the same. You can't multiply a 3 by 4 with a 5 by 2. This is the no-no. Now let's talk about how to put one of these in the calculator. To set up your matrix, you're going to press the alpha button and the window button. And then press the zoom button. Now you can see the top row says number of rows, the bottom row says number of columns. So let's put this first matrix in. How many rows do I have? No, rows go across. No, rows go across. 1, 2, 3. 3 rows. So I enter that. How many columns do I have here? 4. So I enter that, and then I go down to OK. Now, did you see how those spaces in my matrix match up with the spaces I've got here? So I would just put those numbers in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And now I've entered my matrix in the calculator. Okay, I'd like for you guys to go back and enter the second matrix in and tell me what it looks like. Okay, how many of you got something like this? Okay, good. Now we're ready to move on. Now, in your work assignment, there was something called practice problems for solving quadratics. So we're going to solve those using this technique here. So let's look at the first one. The first one gives you three sets of ordered pairs. 1 and 6, 2 and 0, and 5 and 102. Now these are called ordered pairs for a reason. They're called pairs because there's two of them, and the order matters. X always comes first, and then Y. X, and then Y. X, and then Y. Now we're going to take these three ordered pairs and we're going to find the quadratic equation that fits these ordered pairs. Now remember what the quadratic looks like. Y equals some number times x squared plus some number b times x plus a constant. Now that constant could turn out to be 0, but 0 is a good number. So what we're given here are the x and y that goes with this. So for my first equation, I see that y is 6, x is 1, and I don't know what c is. Now, does everyone see where those numbers came from? I found my x, and then I squared it. Then I found my x, and I put it in as a singleton here. So this equation becomes 6 equals 1a plus 1b, and I've got a 1 in front of this c back here. That's my first equation. My second equation becomes 0 equals a times 2 squared plus b times 2 plus c. So I have 0 equals 4a plus 2b plus 1c. And for my third equation, I have 102 equals a times 5 squared plus b times 5 plus c. So this becomes 102 equals 25a plus 5b plus 1c. Now take a look at that. Make sure you see where the numbers came from. Now we're going to take this and write a matrix from that. Now remember, a matrix doesn't have any variables in it. It only has numbers, and those numbers are coefficients. So I have three equations. Each of these equations is a row. And I have three variables. Each of those variables is a column. So this is going to be a 3 by 3 matrix. So it becomes 1, 1, 1, 4, 2, 1, 25, 5, and 1. Okay. Now that's my coefficient matrix. My augment matrix is the y value. So for this first one, my y is 6, then 0, and then 102. So that's my matrix. Now we're going to solve this using the calculator. But the one thing you're going to have to do is put the inverse of this matrix in there to get the right answer. Okay? So let's do that. Second plus 7, 1, 2. So I've cleaned everything out now. Now to get to my matrix, I'm going to go alpha, window, and then zoom. What's the size of this matrix? What are the dimensions of it? How many rows, how many columns? 3 rows and 3 columns. It's called a 3 by 3 matrix. So it looks like this. Now I'm going to put these numbers in. 1, you have to press the enter key after you enter it. Now when you get it all entered, space to the right to get outside. Now, as I said, we need the inverse of this matrix. So you see the key that says x raised to the negative 1? Can you see it? It's right here. That's your inverse key. So you can see what it did. It put a negative 1 out here. Now we have to put in the augmented over here. Now, if you look at this matrix here, it has 3 rows but only 1 column. So that's a 3 by 1 matrix. So second, zoom, 3 by 1, and it looks like that. So we put in 6, 0, and 102. Now, if you can do that, you've solved the problem. Just press the enter key, and that's your answer. Now the 10 represents A, so this becomes y equals 10x squared minus 36x plus 32. Now how do we know this is right? How do we check this? Well, we take our calculator, go to y equals, that's called the equation editor, and put that equation in. 10x squared minus 36x plus 32. Now when you get it in, you want to look at the table, so press second in graph. Remember those 3 points we started with? Find those points in here and see if they match up. When x is 1, y is 6, so that's good. When x is 2, y is 0, so that's good. When x is 5, y is 102, so that's good. So this equation checks. Pretty simple, isn't it? Can you guys do one on your own, or you want me to do another? What? Oh, yeah. Which one would you like to see? Which one? D? picked that because it had some big numbers in it, didn't it? But that's okay. The calculator can handle big numbers. Okay. Now we're going to set up our equations. Y equals ax squared plus bx plus c. So for the first equation, we're going to have 142 equals a times 6 squared plus b times 6 plus c. So that becomes 36a plus 6b plus 1c. For the second equation, we have 238 equals a times 8 squared plus b times 8 plus c. So this becomes 64a plus 8b plus c. And the third equation becomes 62 equals a times 4 squared plus b times 4 plus c, which is 16a plus 4b plus c. Now, we've got 3 equations and 3 variables, so we have a 3 by 3 matrix. The first equation is the first row, but you only want the coefficients. 36, 6, and 1. Second row is the second equation. 64, 8, and 1. In the third row is the third equation, 16, 4, and 1. Now let's double check our numbers. 36, 6, and 1, 64, 8, and 1, 16, 4, and 1. And our Y matrix is going to be 142, 238, and 62. This is a 3 by 3. This is a 3 by 1. So we can multiply those. Okay. Let's go back into the matrix menu now. Alpha, window, zoom. Now this is a 3 by 3 matrix, so we're going to set that up. And put our numbers in. 36, 6, 1, 64, 8, 1, 16, 4, and 1. So it should look like this. I don't know if you can see that or not. Now we're going to space outside and do the inverse. And then we have to get this Y matrix here. This is a 3 by 1. So second, window, zoom, 3 by 1. And our numbers become 142, 238, and 62. Space outside. Press the enter key, and you see our equation becomes y equals 2x squared plus 20x minus 50. Now, how do we check that? Go to y equals. Now, we call this y equals. This is really an equation editor, so try to work that into your terminology if you can. Okay, put that in the equation editor. Look at the table. When x is 6, we get y is 142. When x is 4, y is 62. When x is 8, y is 238. So we have a good solution. Now, any questions over that? Okay, you guys try one here on your own. Let's go with, well, you guys gave me some big numbers. Let's do C here. Can you see C from back there? Make it a little bigger. Well, I'll write it down for you. First pair is 3 and 43. Then 4 and 61. Then 11 and 299. Okay. Now, we have to be aware of COVID, but I would really like to hear you guys talking to each other from behind your mask. Okay, let's set it up and go from there. First equation is 43 equals 9a plus 3b plus c. Second equation is 61 equals 16a plus 4b plus c. Last equation is 299 equals 121a plus 11b plus c. So let's put this into our matrix. That's a 3 by 3. So we're going to get 9, 3, 1, 16, 4, 1, 1, 2, 1, 11, and 1. Space outside and do the inverse. And then let's put in our y, our put it on suck and quit. We're going to put in a 3 by 1. What happened here? I think I messed up, guys. A 3 by 3. Then I'm going to put in 9, 3, 1, 16, 4, 1, 1, 2, 1, 11, and 1. With the inverse of that, and then I want a 3 by 1. And I put in 43, 61, and 299. And the answer I get is y equals 2x squared plus 4x plus 13. Anyone else get that answer? Now, can you do a few of these on your own? Now remember, I'm going to post the video tonight, so it'll be up there. Let's look at one of your assignments. Now, there are videos for you to watch in there too, so. Let's look at homework 2. Okay, can you guys see this one? Is it big enough? Now let's just work this with a calculator. First I'm going to clear it. Second plus 7, 1, 2. Now I'm going to put my matrix in. Now you see how I have 3 variables and 3 equations? That's a 3 by 3 matrix. Now for the first matrix, the first row, I'm going to put in -6, -4, and 3. -2, +5, +z. Then I have 1 for x, -5, and 6. So -6, -4, and 3, -2, 5, and 1, 1, -5, and 6, and I did the inverse. Okay, is everyone ready? Now we're going to put in the Y matrix. That's going to be a 3 by 1. And that becomes 7, 15, -19. Now press the enter button, and we see the answer should be -3, 2, and -1. Which answer choice is that? Can you see it? So this is not hard, is it? Okay. Any questions? How many of you can get into Schoology from your cell phone? Then why don't you guys do week 7 homework 2? Good, young man? What's wrong? Oh.